Assalamu alaikum and welcome to MEC 101 Statics.
In this introduction, we're going to break down exactly what this course is all about. We'll cover what statics actually is, why it's so incredibly important for you as an engineer, and how we're going to tackle it together this semester. So let's dive right in.
All right, first things first. What exactly are we talking about when we say statics?
Well, at its heart, statics is a key part of engineering mechanics, and it's really all about things that are, well, static, things that aren't moving. We're going to study all the different forces, the pushes and pulls acting on an object, and more importantly, how all those forces perfectly balance each other out. This perfect balance is what we call equilibrium.
Now, to make sense of the real world, we have to simplify things a little. We'll focus on two main ideas. First, we have the particle. You can think of this as just a single point in space that has mass, but its size doesn't matter for our calculations. And second, we have the rigid body. This is any object that we assume is so strong it won't bend, stretch, or deform at all, no matter the forces we apply. These two concepts are going to be our building blocks for solving problems.
Okay, so we know what statics is. But now for the big question. Why does it matter so much? Why is this one of the most essential subjects you'll ever study? Think about it. Every day, you trust that bridges won't collapse, buildings won't fall down, and the car you're in will hold together. That safety doesn't happen by accident. It's the direct result of good engineering. The fundamental job of an engineer is to make sure that these structures can handle every single load and force they'll ever face, and do it without breaking or, moving when they shouldn't.
And this is where statics comes to the rescue. It gives us the exact tools we need. Our goal as engineers is always to design for that perfect state of equilibrium. It means that if you add up all the forces pushing and pulling, they have to equal zero. And if you add up all the twisting forces, what we call moments, they also have to equal zero. It's this perfect balance that guarantees stability.
And let's be absolutely clear. The stakes here are incredibly high. Getting this right is the difference between a functional, safe design and a complete disaster. Mastering statics isn't just about passing a course. It's a fundamental responsibility for anyone who's going to be designing things that people rely on. So let's connect the dots. How does all this theory actually play out in the real world of an engineering career? The short answer is, it's everywhere. The principles you're about to learn are the foundation for the design of giant skyscrapers and massive bridges, for sure, but they're also crucial for the car you drive, the machines in a factory, pretty much any mechanical system. This course is the bedrock for all the advanced subjects that come next, like strength of materials and machine design. So when do we use it? Right at the beginning of the design process. As soon as you have a concept, the very next step is a statics analysis. You have to prove, mathematically, that your idea is stable and in equilibrium before you can move on. Think of it as the first, most critical safety check for any design.
All right, so how are we going to do all this? You might be thinking it sounds pretty complicated, but the best part about statics is that there's a clear, logical system for solving problems.
We're going to use a really powerful three-step method for almost everything. Step 1, and this is the most important skill you'll learn, is drawing a free body diagram. It's just a simple sketch that isolates an object and shows all the forces acting on it. Step 2, you'll take that diagram and apply our key formulas, the equations of equilibrium. And finally, step 3, you just solve the math to find what you're looking for. It's a straightforward, repeatable process, and you're going to get very good at it.
So, what does your journey through this course actually look like? Let's quickly go over the roadmap.
We've set up the course to build your knowledge one step at a time. We'll start with the absolute basics and core principles. Then, we'll apply those ideas first to particles, and then level up to more complex rigid bodies. After that, we get into the really cool stuff, like analyzing real-world structures. And we'll finish off with essential topics like friction, centroids, and moments of inertia. Each chapter builds directly on the last one.
So here's the ultimate goal. By the end of MEC 111, you won't just know a bunch of theories, you will have a real practical skill. You'll be able to look at a complex engineering problem, break it down, analyze the forces, and solve it with genuine confidence.
So, as we get started on this journey together, I'll just leave you with this one question. Are you ready to learn the principles that will empower you to build the future and to build it safely?
Welcome to MEC111 Statics.